I'm going to show you how to troubleshoot a gas dryer that won't heat, won't start, dries too hot, takes too long to dry, heats intermittently, or won't stop. Before you work on your dryer, unplug the dryer and turn off the gas. This is a Kenmore 90 series gas dryer I'm working on. We're going to test each of these components: thermal fuse, cycling thermostat, high limit thermostat, flame sensor, igniter, and the coils. Here's my recommendation. I would test all of these components. The reason I would test all of them is that some of them share the same failure symptoms. For example, the cycling thermostat and the high limit thermostat can cause your dryer to take a long time to dry. So if you test them all when you're in your dryer, you don't have to go back in and test them again. Most gas dryers have the same components as this gas dryer. They may look different, or they may be located in a different location based on the make and model of your gas dryer. Now we're going to test each of the components. I'm also going to talk about the problems that each of these components may cause or present if they're failing, weak, or have failed. If I were to test the components in a gas dryer, I would test them in the sequence that I'm going to show you. We're going to start with what's called the thermal fuse. Thermal fuses have been on gas dryers since the 1980s. The purpose of a thermal fuse is to prevent your gas dryer from overheating and causing a fire. You'll find the thermal fuse on what's called the blower housing. This is the blower housing. That's the exhaust. The most common reason that a thermal fuse will blow is that there's an obstruction in the lint screen housing, the blower housing, the exhaust, or the ducting at the back of the dryer. The ducting at the back of your dryer can be kinked, but more than likely the obstruction is lint buildup somewhere in the exhaust system. This is the lint trap housing. It goes toward the front of the dryer. You'll see it as you're taking the dryer apart. This housing came off another dryer, not mine. But look at all that lint and buildup. See it in there also? If that thermal fuse blows, it's not resettable, so your dryer either won't start or it won't heat. The thermal fuse is the most common part to fail on a gas dryer. If your thermal fuse fails, before you put your dryer back together, I would clean out the lint trap housing, the blower housing, the exhaust, and the ducting at the back of your dryer. Now we're going to test the thermal fuse. I'm going to remove each component to test it. I'm doing that for two reasons. One, with the component removed from the gas dryer, I have a little bit more confidence in my test. And two, in removing this, I'll be able to show you how you replace it if you need to replace it. I used whiteout and dabbed a little bit on the component and one connection on each of the components so that it's easier for me to figure out where the wires go back onto. Remove the connections. 1/4 inch nut driver. This is an analog multimeter. This is a digital multimeter from Harbor Freight. $7.99. If y'all don't have one, just go to Harbor Freight and get one. This is another digital multimeter. This one beeps when I have continuity. So you'll hear a beeping here. That will display numbers. And this, if I have continuity, in that thermal fuse will go to 0. It doesn't matter what type of multimeter you use as long as you know how to read it. The first thing you want to do is touch your probes together and see what the reading is. Or if it beeps in this case, and it will show a reading. There you go. So we're going to test the thermal fuse now. There you go. We know we have continuity. Now we're going to test with the little Harbor Freight multimeter. First, I'm going to put the probes together, see what the reading is on this multimeter. This multimeter tends to jump around, so that's why I check the reading first. I should come back at about a 5 on this thermal fuse if I have continuity. So let's see what we have here. There you go. So we have continuity. Now we're going to test on the analog. What you should see if we have continuity is that this dial will move to the 0. It doesn't matter whether the positive or negative probe go on either side of this thermal fuse. You're just testing for continuity here. So here we go. There you go. We have continuity on all 3 multimeters. So from here on out, I'm not going to test on each of them. I'm going to rely upon this one because it's easiest for me. Now we know our thermal fuse has continuity. And what does that mean? That means that there's an unobstructed path of current that can travel through this thermal fuse. If this thermal fuse had blown, that path, electrical path, would be broken and the current can't run through it. But our thermal fuse is good, so we can put it back on. Before you put it back on, make sure you clean it. Now we're moving on to the cycling thermostat. What the cycling thermostat does is regulate the heat in the drum of your dryer. If the cycling thermostat fails or malfunctions, the dryer will heat too hot, will take too long to dry, will heat intermittently, won't heat at all, or it won't turn off. Now we're going to test the cycling thermostat. The cycling thermostat can get covered with lint buildup, so you should clean this off. Also, if you use fabric softener, you're likely going to have a lot of buildup on this cycling thermostat and also on that thermal fuse. You want to test it on these 2 terminals, not those 2. We have continuity and we now know that our cycling thermostat is good. So now we're putting the cycling thermostat back on. Now we're going to move on to the high limit thermostat. This is the high limit thermostat. You'll find it on the burner housing. When the cabinet of the dryer, the inside of it, gets too hot, it will trip this thermostat, which cuts the power to the burner. It's a safety feature. As the inside of the cabinet cools down, the thermostat resets and ignites the burner again. What can cause the high limit thermostat to trip on and off is either poor airflow within the cabinet area of your dryer, or it could be malfunctioning. If the high limit thermostat fails or malfunctions, the dryer won't heat or the dry time will be too long because the thermostat will trip, cut the burner, the thermostat will cool off, reignite the burner, and those short heating cycles will repeat. Now we're going to test the high limit thermostat. I'm using a 1/4 inch ratchet and socket to remove the screws because of the angle and the tight space. We're going to test the high limit thermostat. Now we know that our high limit thermostat is working properly. Now we're moving on to the igniter. This is the igniter. It's not common for an igniter to fail. I'm going to show you how to test that. Unplug the connection. There's one screw to remove right there. This is the filament of the igniter. You don't want to touch that with your fingers. So just hold it here when you handle it. There are 2 pins in this connection that you touch the probes of your multimeter to. We're looking for a reading between 50 and 400 ohms. We have 133, so we know this igniter is good. We're putting the igniter back in. Reconnect the igniter. Now we're moving on to the flame sensor. This is the flame sensor. The flame sensor detects whether the igniter is hot enough to ignite the burner. If it is, the flame sensor cuts the current to the igniter and diverts the current over here to the gas valve coils. The coils open the valve, gas is released, and it ignites the burner. If the flame sensor fails or malfunctions, the current will continue to flow to the igniter, so the igniter will continue to glow. But there won't be any current diverted to these coils, so the gas valve won't open, the gas won't flow, and the burner won't ignite. Some dryers have a kick panel or lower panel, like mine does, that I can remove. Some dryers have a solid panel in the front and a little viewport, a little square one, right about here in front of that burner housing. And the viewport will have a little cap on it. You remove that cap. If your dryer has a lower kick panel to remove or a viewport, before you unplug the dryer and turn off the gas, turn the dryer on to a heat setting, not air, heat, and then look through that viewport or through this access area into that burner housing and see if that igniter is glowing. If that igniter glows and then the burner comes on, you know that you don't have a problem with the flame sensor. If the igniter continues to glow and the burner never lights, you know that your flame sensor is malfunctioning and needs to be replaced. Now we're going to test the flame sensor. Remove the connections. We know the flame sensor is working properly because we have continuity. Now we're going to put the flame sensor back on. Reconnect the wires. The last component we'll check are these coils. There's two of them, one here and one there. They rest on top of the gas valve. It's not common for a gas valve to fail. If the coils fail or are malfunctioning, the dryer won't heat, will heat intermittently, or the dry time will be too long. If your igniter is working, it's glowing, it goes off, it glows again, and continues that pattern, but no burner ignites, you know this: the igniter's working, the flame sensor's working, because it's cutting the power to the igniter and diverting it over to the coils, but the coils are not opening the valve, so the gas isn't flowing through to turn on the burner. If these coils fail completely, the igniter will glow on and off, but the burner will never light. If the coils are weak or failing, the burner will behave erratically, meaning this: it may come on and only stay on for a couple of seconds and then quit. Or the burner may light on the initial cycle and maybe a couple of cycles thereafter, but then it won't light anymore because the coils are failing. If your dryer is experiencing intermittent heating or the dry time is too long, I would look at the coils. We can test these, but if they're malfunctioning, they may well test back at a false positive. Because when they're cool, they may work, but as they heat up, they'll fail. So I wouldn't go through the hassle of putting my dryer back together. If I had any concern that these coils are bad or failing, I'd replace them. I'm going to show you how to remove these coils. Remove this bracket. Remove the coils. This coil has a sleeve in it. You don't want to lose that. Remove the connection. Remove the other coil. Remove the connection. We're going to test the 2-prong coil first. It should have a resistance of 1,000 to 2,000 ohms. And it has 1234. Here's how you test the 3-prong. The number 1 terminal is right there. There's a number 1. So you put your probe there and put it on the second terminal. We should get a reading between 300 and 2,000. We have 1381. Now, put a probe on number 1 and on number 3. And we should get a reading between 300 and 2,000. We have 566, we're good. So even though we're getting proper readings on these, it can be a false positive on one or both. Now we're going to put the coils back on. Put the connections on. Make sure the sleeve is on for this 3-prong coil. You want to check your connections and make sure they're good. Make sure both coils are fully seated. Put the bracket back on. If the readings on your coils were good and you didn't replace them, but you continue to have problems with your dryer, with intermittent heating or dry times that are too long, I would consider replacing the coils. That's how you troubleshoot a gas dryer that won't heat, won't start, heats too hot, takes too long to heat, heats intermittently, or won't stop. Hope it helps, and happy DIY.